Okay, welcome everybody. I wanted to make a quick YouTube video for all of my linear algebra students so they can see how I like to solve problems in Sage in a way that you can kind of follow how you do a Gaussian elimination step by step. I wanted to show you how to enter the matrices and how to compile stuff. So first off, you want to go to Cocalc.com, create an account, and then you want to hit create new file, and then you want to make sure that you create a new Sage worksheet. Because Sage has the built-in functions to handle linear algebra. Okay, and the first thing you want to do is to type in a matrix. So A is going to be a matrix, and we need to give it a list L to create that matrix from. So L will be a list of lists. Every list is a row here. And so if I'm going to make a 3 by 3 matrix, I need to have 3 rows. And then I was planning on doing this for problem number 2. So problem number 2 says we want to solve this 3 by 3 system using Gauss-Jordan elimination. That just means do row reduction until you get into reduced row echelon form. And so we have x minus y plus 2z is equal to 2. 2x plus y plus z is equal to 3i. And then x plus y plus z is equal to I. So I'm going to enter that into a matrix here. So let's see, 1, negative 1, 2, 2 is what I need to put into the the row here. So 1, negative 1, 2, comma 2, and I'm actually going to leave the last row off for a second, and I'll enter that a little bit later. So I have 2, 1, 1 is my next row, 2, 1, 1. And then my last row is 1, 1, 1. 1, comma 1, comma 1. Okay, so there's a list of lists, and then I take A and I say take L and make that into a matrix, and now I need to type print A. Okay, so that is the coefficient matrix for this system right here. And then the constant matrix is going to be 2, 3, I, and I. Okay, and so I'm going to type B is the matrix, and rather than typing the list in separately, I'm just going to go ahead and make a matrix with 3 rows like this. So I think it was, let's see, 2, 3i, and I. 3i and I. And notice you have to have columns in between each list. And if you're going to take a scalar times I, you need to put a star there so it knows to multiply those, and it's not treating 3i as some type of string or something. Okay, so if I do that and I print B, then it prints like that. That's good. And if right now, if I try to augment A and add B, it's going to throw me an error. And the reason for that is that A right now, I think it thinks that the coefficients in A are only integers. And so it says can't coerce 3 times I into an integer, and that's because it's thinking that A is a matrix that should only have integers, it shouldn't have complex numbers. So I need to go back and tell Sage that it should have a coefficient field of C. So if the coefficients are C, or complex numbers, or you can also just type out complex field, I think, and then put in the number of precisions you want. So I think that will do it. Yeah. And so this is just saying it's only going to print to the tens place. If I just type in CC, it's going to give me a lot more decimal places. So let me just very quickly show you that. If I plug in CC, it knows its coefficients, but the default setting is for like thousandths of precision or something. So let me go back and type in complex field 10. Okay, so that will keep the answers at least relatively readable. Okay, so there's A augment B. So that's how you'd enter in these matrices. Again, remember that you have to type shift comma enter to run a cell, or you can just hit run. Okay. Now the next step that I want to go over is how to make an elementary matrix. And so an elementary matrix is always going to be, for at least if you're doing a 3 by 3 problem, it's always going to be a 3 by 3 matrix that is square. Let's see. and it should look something like the identity. It's not always going to be the identity. It could be a permutation matrix, or it could be a matrix that scales things and adds them to another, but I always start with just typing in the identity first and then printing it to make sure that everything looks good. Okay, so there's the identity. And now remember that we want to do Gaussian elimination, we want to take 2 times row 1 and add it to row 2, and then replace row 2 with that result, and that will make this 0. And so I need to put a -2 in the 2, 1 position. I don't know what's going on here. Okay, and I need to put a -2 right there. And now if I print E1 times A, it does that. And now notice that, like, I did A dot augment B, but then when I went E1 times A, it went back to a 3 by 3. And the reason for that is that A dot augment B does not change A. It just takes A and adds B to it. So if I want to save this, I need to save this as a different matrix. Like, I'll say C is equal to A augment B, and then it'll remember to store C as that. So I'll do this, and then I'll print C. And so if I want to do Gaussian elimination to that whole augmented matrix, I should really take E1 times C. And now you can see that this matrix, when I multiplied on the left, did zero out the first entry of row 2. And so that was, again, taking -2 times row 1 and adding it to row 2, and replacing row 2 with the result. Okay, so next I want to make this a 0. And so what I need to do is multiply by E2, which I need to define. E2 will be essentially the same sort of thing, but now I'm going to have a -1 in the 3, 1 position. And that's going to take -1 times row 1 and add it to row 3 and replace row 3 with the result. And of course I don't want to make that E1. If I redefine that to be E1, then Sage will forget that I defined E1 to be something different a minute ago. So I'm going to compile E1, E1C, and then compile E2, and now I know E2 is that matrix. And now I should print E2 times E1 times C. Okay? And so now I've zeroed that out. Now I need to scale that entry to be a 1. So I'm going to define a slightly different elementary matrix, and that one will be like so. It looks like the identity, but it is going to scale the second row by a 1/3. So I need to redefine this to be 1 0 0 0 1/3 0 0 1. And now I'm just going to copy this portion right here and print E3 times E2 times EC times E1 times C. Okay, Shift Enter. Now I've scaled this and made it a 1. The last thing to do is to zero out this row by taking -2 times row 2 and adding it to row 3, and then replacing row 3 with that. So that's going to be my matrix E4. Okay, print, and now I'm going to print E4 times E3 times the rest of the steps. So E4 times that. Okay, so now I've figured out that Z should be 2/3 minus I, and then I haven't quite figured out what Y should be, although I could, by substituting Z back into this equation, come up with that. But I might as well just do the Gaussian elimination step using the elementary matrix E5, which I'm about to define. So E5 is going to be an upper triangular matrix. So notice that when you're zeroing out things below the diagonal here, you wanted to multiply by lower triangular matrix. Now I'm going to be zeroing out that one right there. So I will multiply by an upper triangular matrix that will take 1 times row 2 and add it to row 1 times row 3 and add it to row 2, and then replace row 2 with the result. So print E5 times E4 times E3 times E2 times E1 times C, and now I've zeroed out this entry Now I need to zero out that entry. So I'm going to multiply by E6, and that will be an upper triangular matrix with a -2 in that position, in the 1, 3 position. E6 times that. Okay, now I have a 0 there. And finally I have one last matrix to multiply by. I need to multiply by E7, which will have a 1 in the 1, 2 position. So E7 is going to be a 1 there and a 0 there. So I print that. Again, that's going to scale this appropriately. Okay, so I now have a identity matrix in the block where A was, and I have my solution vector right here. So the answer should be 2i, -2/3, and then 2/3 minus I. Okay, so that is how I would write down this problem. If you print this to a PDF, I'll be able to follow your steps, and I'll know exactly what row operations you did and when. So to print to a PDF, you just click Convert to PDF, generate that, and then you'll be able to download that and then upload it to to Canvas. And this is still a little messy. I'm going to show you in a later video how to convert this into a much nicer file using LaTeX, but that's something we'll cover in a little bit. All right, thanks.